This iOS app is making over $50,000 a month, and I cloned the entire app without writing a single line of code. The app I created isn't some basic one either. It's a fully functional insect identification tool with premium features, payment processing with Stripe, and everything a professional app needs. The craziest part, I built the entire thing using only one AI tool. Most people think you need years of coding experience or a team of expensive developers to create profitable apps. But that's completely outdated thinking. The reality is that AI has fundamentally changed what's possible, and I'm going to show you exactly how I did it. In this video, I'll walk you through my step-by-step process for creating this app from scratch, show you the exact AI tool I used, and reveal how I set up the monetization so you can start making money right away. Whether you're a complete beginner or someone who's tried app development before, this could be the most valuable video you watch this year. I've spent months perfecting the system, and today I'm sharing everything. No secrets held back. Let's dive in. Alright, so we're gonna build the app in Replit. You will get $10 worth of free credits if you use my link in the description. The goal for this project was simple. Build a feature-rich bug identification app from scratch. Something inspired by Picture Insect, but custom built inside Replit. I wanted real-time scanning, photo uploads, multiple angle support, and a confidence score, all powered by AI. So let's kick things off with this prompt. We will be building a bug identifier app with the help of Gemini API. The primary feature will be the identification. The app should have camera integration for real-time insect scanning, allow users to upload photos from the device gallery, support multiple angles, and show a confidence percentage for identification accuracy. Replit kicks things off by asking me to confirm the app plan and lists a bunch of helpful features it'll include. Just say yes because it streamlines everything. You can also see that it's asking for a Gemini API key, and if you don't have one, just Google Get Gemini API key. It's super easy. Once everything's wired up, we can now test the first real upload. Boom! It breaks. The app crashes when I upload an HEIC file from my phone. Even large JPGs throw errors. Turns out the file format and size limits weren't properly handled. Okay, let's use the prompt allow uploading of JPEG, PNG, and WebP files, block unsupported formats like HEIC, and display a clean error message if the file is too large. Now, uploads are smooth with clear error prompts when needed. Okay, on to the identification itself. Once an image is in, the app sends it to the Gemini API and returns the bug's common name, scientific name, and a confidence percentage. But early on, the layout was a mess, just raw data on the screen. We can use Replit to redesign the result page with a clean layout. Make the identification results display with the bug's name, a photo preview, and a large readable confidence score. Add a save button to let users store the result in a logbook. Everything's finally looking the way it should. You've got the bug name front and center, a neat photo preview, and a confidence percentage in big, bold text. If you like the result, hit save and it gets added to your personal logbook for future reference. Nobody wants to open an app and get dropped into a blank screen. So before we go deeper with the features, we need a landing page that actually explains what the app is and why it's useful. Something that gives first-time users a quick overview without overwhelming them. So I'll start by prompting, good, next provide a good-looking landing page with a nice overview of the features. Right away, Replit starts generating a clean layout. At the top, there's a hero banner with a short, punchy headline and tagline. Below that, we've got a section to highlight the main features. We can also see here that it includes the camera sensor, pest detection, species comparison, and an education hub. Each one of these gets its own icon and short description, which makes the whole thing appear super easy to skim. And then Replit prompts about adding a database. Let's respond yes to that because we'll need that later for saving scan history, user preferences, and logbook entries. Now let's give the landing page a little personality. I'll add add hover animations to the feature icons. That gives each icon a smooth bounce or color shift when you hover, just enough to make it feel interactive, not overdone. While reviewing, I noticed some spacing and font issues, but Replit automatically cleans that up. It adjusts the padding, balances the typography, and makes sure the entire page is responsive on both desktop and mobile. To wrap things up, let's add a top navigation bar so users can move around easily. Add a top navigation bar linking to login, identification, journal, and learn pages. The links show up right where they should, and everything routes properly. Now we've got a landing page that actually works. It gives users a clear idea of what the app offers, shows off the core features, and makes it easy to dive in. No confusion, no clutter, just a smooth starting point that feels ready for real users. If someone's going to use this app more than once, we've got to give them a way to save their data. There's no point identifying bugs if everything disappears the moment you close the tab. So to make that possible, let's send a prompt. I need you to implement user authentication. This would allow users to save the identified bugs in their respective accounts. This kicks off the whole login system. I'll set this up so users can register, log in, and log out, all backed by a connected database to keep their info secure. Once that's in place, each person gets their own account with a personalized logbook. Every time they identify a bug, the app will save it under their profile, along with the species name, the data, the uploaded image, and any notes they want to add. This turns the app into more than just a one-time tool. Now, it's something users can come back to over time. What's cool is that after I had Replit fix a small mistake in the landing page, it went ahead and checked the rest of the app too, cleaned up everything else that might have caused problems. Now that users can log in and save stuff, it just makes the app feel more useful. You're not starting from scratch every time because you've got a place to keep track of everything you've found, and it's all there when you come back. Identifying the bug is great, but most people want to know more than just the name. Is it dangerous? Should I get rid of it? Is it helping my garden or ruining it? To make this happen, we can prompt. Next, we will implement additional information features like the following. Threat level assessment, harmful, beneficial, or neutral, pest control recommendations, environmental impact information, similar species comparison, and conservation status. Right after that, the app starts pulling in way more detailed data. You can see here that once a bug is identified, it now shows a full breakdown that covers everything from threat level to how it affects the environment. You get a clear label showing whether it's harmful, beneficial, or neutral. So no more guessing whether that thing crawling on your wall is a friend or foe. It also gives practical pest control tips like when to use natural remedies versus chemical options. Then there's the environmental role. It'll tell you if the insect is a pollinator, decomposer, invasive species, or something else entirely. That alone makes this feature super useful for gardeners or anyone into sustainability. The app also shows where the insect is commonly found and its conservation status, so you'll know if it's endangered, common, or invasive in your area. And just to avoid any confusion, it even pulls in visual comparisons to lookalike species, so you're not misidentifying something that just looks similar. Now, at first, this part was kind of spotty. I'd upload some random bugs and the info would either come back incomplete or the whole thing would time out. After letting Replit know, it automatically adjusted for larger file sizes, and that helped a lot. There were also times when the Gemini API didn't return the full set of attributes, so I added a follow-up prompt to pull missing details using alternate model queries, and that did the trick. Now, every scan comes back with a full report. You're not just identifying a bug, but also you're learning about its behavior, impact, and how to deal with it if needed. Super helpful stuff. At this point, the app's great for solo use, but adding a community element takes it to a whole new level. To make this happen, I'll use the prompt. Next, implement user interaction components, including the following. Community identification verification, user-submitted insect sightings, geolocation tagging, personal insect spotting journal/log. This adds a full community layer. Users can now share their sightings with others, complete with a species name, a photo, optional GPS tagging, and any notes. Other users can upvote or flag the ID if it seems off, and there's also a button in each post to mark whether the identification seems accurate or needs review. So it's easy for the community to give quick feedback. At the same time, each user gets a personal journal that auto-updates every time they scan something. Entries include the bug's name, photo, and any notes. Plus, you can edit, sort, or search through them by species or location. With this, you're not just scanning bugs anymore. You're sharing what you find, seeing what others are spotting, and slowly building your own collection without even thinking about it. Given that everything else is now running smoothly, let's shift focus to making the app more than just a tool. It should also teach people something. Let's start with a prompt. Everything is working now. Next, implement an educational resources feature. Include the following: insect facts, detailed taxonomic information, education articles, and interactive learning modules about entomology. That sets up a whole new learning section inside the app. Every time you visit, you get a bite-sized insect fact, just something quick and interesting to keep things fresh. There's also a growing library of articles on topics like insect anatomy, pollination, ecology, and the difference between pests and beneficial species. For people who want to go deeper, we can add a visual taxonomy chart that breaks down common insect families. And to make learning more fun, I'll also include interactive modules, stuff like quizzes and drag-and-drop games to reinforce what you picked up. The goal here is to make the app useful not just for identifying bugs, but for learning about them too. Now that the core features and education tools are in place, it's time to add something smarter, something that actually predicts what bugs you might see based on where you are. Let's start by prompting, now implement advanced features. In this case, implement weather and seasonal insect activity predictions based on location. Replit immediately asks for an API key from OpenWeatherMap, and it also gives step-by-step instructions on how to get it, so the setup's pretty straightforward. Once that's connected, the app starts pulling in weather and location data. Now, based on your current region and the time of year, it shows which insects you're most likely to encounter. So if it's spring and you're in a flower-heavy area, you'll probably see pollinators like bees or butterflies. In summer, the app might warn you about mosquitoes or wasps picking up in your area. Users can choose to enable location access, which is totally optional, and once it's on, the predictions dashboard lights up. It uses a mix of maps, time charts, and little insect icons to make the data super visual and easy to understand. This feature adds a whole new layer to the app. Instead of just reacting to what you find, you can start anticipating what's around, almost like a weather forecast, but for bugs. Once the app started coming along, it hit me. This might actually be something people stick with, so why not give them more to unlock? Let's make it happen through this prompt. Implement premium subscriptions using Stripe. Replit sets up the flow for subscriptions, and now users can upgrade to unlock extra features. The free tier covers the basics, but with premium, they get unlimited scans, full access to the educational hub, enhanced AI detail, pest forecasts based on location, and cloud syncing for their journal across devices. To be honest, getting Stripe to behave is not totally smooth. Some subscriptions here are not syncing properly, and webhook responses are kind of a mess. You can see here that I have to prompt Replit to switch up the webhook method and make sure login sessions are validating tokens correctly. But running everything in test mode will help us spot the issue. And look, after a few tweaks, it all worked the way it should. And honestly, that's been the pattern through this whole project. Upload issues, API hiccups, Stripe glitches, and they all popped up at some point. But with the right prompts and a bit of trial and error, each problem gets sorted. Half the time, Replit even improved other parts of the app while fixing the thing I asked for. Now, with premium features up and running, the app's not just functional. It's something people can actually grow with. Adding premium really shifted the feel of the whole build. It went from being a fun side project to something that could actually support a real user base. Everything's connected, it runs smoothly, and now there's a reason for people to keep coming back. This whole thing started as a simple idea and a few prompts, and somehow turned into a fully working app. From scanning bugs to community features to a full premium setup, everything was built without writing any code. Just goes to show what you can pull off with the right tools and a bit of patience. Thanks for watching, and I'll see you in the next one.